In this lesson, we are going to create a system of equations. So we're not going to actually solve the system. We'll do that in the next lesson. So let's go ahead and get started. First of all, I'd like to review what is a system of equations. What is it showing us? And if you recall, a system of equations is two or more equations, and here you see I have two equations. The red one here, negative x plus 20, and the blue one here, negative 2x plus 35. And those two equations intersect here at this point 15, comma 5. And so what that means is that 15 and 5 are the solutions to this system of equations. So all the other parts of each of these graphs may not be even relevant to the problem at hand. What we're interested in is the intersection. So the two equations together, or the two graphs together, give us our answer. And so let's go ahead and look at a problem. Create a system of two equations. Sewing students made some shabby cell phone, should say shabby chic cell phone cases, and marketed them on Etsy. And some were cork, made of cork fabric, $6 each. And some were marine vinyl, $4 each. After 6 months, they sold a total of 480 cases, totaling $2,340. How many were cork and how many were marine vinyl? So we're looking for a quantity here. That's what we're looking for. How many, which is the quantity. So let's see how we should go about solving that. Now, if you'll notice, I color-coded this problem for you. So I kind of gave you a little bit of a hint. This is the answer. So I'm giving you the answer just so that we know that our equations are correct when we go ahead and do them by the end of this lesson. Because our interest in this lesson is not getting the answer. Our interest is creating the two equations. So let's recall a few things about systems of two equations. A system of two equations involving money, which this involves money, has two variables which usually represent quantities of each thing. So two variables which represent the quantities of each thing. So what do you think those two variables would be that would represent the quantities? Well, they want a quantity here. How many were cork and how many were marine vinyl? So I would probably say that the variables are cork, or C. And our other variable would be our marine vinyl. We'll just call it M. The other thing that systems of two equations involving money has, there's usually two money amounts that relate to each of the quantities. Well, what are the money amounts in this problem? Well, which money amount relates to the C, the cork? Well, we said that the cork was $6 for each one. So we could put a 6 there. We could even put our dollar sign just so we make sure we understand. And then what is the money amount that relates to our other quantity, M? Well, our marine vinyl is $4 for each one. So those are our two money amounts relating to each of our quantities. And the other characteristic of a system of two equations involving money is that it has a total for the quantities. We can see that the total for our quantities was given to us. And that total is 480. That's how many were sold total. And then one more characteristic, it also includes a total for the money amounts. So not just a total for the quantities, but for the money amounts, we usually get a total. And so what is our total money amount? Well, it's right here, 2340. So we'll write that down. So these were all the things here, these three, actually four if you count them separately, these were given to us. And this is our variable that we have to find. So once we have all of those items filled in that were given and what they want us to find, I think that we have enough now to go ahead and create our systems. So let's create our first equation just simply out of our variables and our total. So we can see that these variables here, which represents the quantities of cork and the quantities of marine vinyl, well, those variables should total 480. So let's go ahead and write that. Our cork plus our marine vinyl should equal 480 total. So that's our first equation. So then what's left are these three. This is an expression, this is an expression, and this is a monetary amount. So can we make an equation out of that? Well, yes, we can, because $6 times each cork that was sold plus $4 times each marine vinyl that was sold equals $2,340. So $6 times each cork plus $4 times each marine vinyl. Remember, these give us a monetary amount. That equals $2,340. And since I gave you the answer, we can check to see if our equations are right quickly, just for the sake of creating an equation and making sure that we have the intuition down pat. So if we were to put 210 up here above this first equation, 210 plus 270, does that equal our 480? It absolutely does. So it checks there. Let's put it here. $6 times 210 for the cork plus $4 times 270, and let's go ahead and check our math. Well, 6 times 210 is 1260, and 4 times 270 is 1080, and that equals 2340. So it looks like we did it right. And let's go ahead and look at these two equations in a graph. So if we were to graph these two equations, we would see that our intersection would be this 210 and this 270. Well, how is that? Well, when we go to graph it, we usually make one of these an X and one of these a Y, just because that's what we're used to seeing. So we would have X plus Y equals 480. And we always have the y by itself, so our equation would be y equals negative x plus 480. So that would be one of our equations. And then for this one, let's try and simplify that. That would be, we'd have x and y, so we'd have 6x plus 4y equals 2340. And we want to get the y by itself, so we'd have 4y equals negative 6x plus 2340. And we have to divide both sides by 4, so here we get y equals, remember we're going to divide both of these terms by 4, so it'd be negative 6 over 4, which is really just 1.5 x, and then 2340 divided by 4 is 585. So this is our second equation. And if we graphed both of these, our x, remember, is the 210, and our y would be the 270. That's where they should intersect. So let's go see that graph. We have y equals negative x plus 480, that's the red one. And we have y equals negative 1.5x plus 585 here. That's the blue one. And here is their intersection, and lo and behold, it's 210 and 270. So x was representing our uh, our cork. So the x-axis, the x-coordinate here is representing the amount of cork fabric that was sold, and the y-coordinate, the 270, is representing the marine vinyl that was sold. And this little point right here is the only point that is really true. I mean, this is what really happened. The rest of this line, yes, there are points here, and if I clicked here, that point, yeah, I guess they could have sold this much, but these two amounts don't add up to what we needed, 74 and 474. Our total is supposed to be 480, and 74 plus 484 is only 558, or is 558, I should say. So that's one thing to remember about systems of equations, is that the rest of the points on both of these lines, yes, they could be possibilities, but they're not the actual thing that happened in our actual situation. This is the only point that represents what really happened in our situation. So there you go. So in the next exercise, I'll give you another problem, and this time I won't give you the answer at all. So you'll have to come up with the equations and you'll have to solve them. Well, good luck, and I know you'll do great.